Good evening, everyone. This is Vikram again. Welcome all to session 18. So we'll just wait for a couple of more minutes for others to join. So then we'll get started. Okay. Yeah, Kavita, do you have any question? So it's like you have put something like int a is equal to 1, 2, 3, 4, 5 array, right? So what is the question you have? What is the doubt you have? Let me unmute you. Yeah, you can speak.
Yeah. Yeah. Are you able to hear me?
Yeah.
Okay. No, I mean in last session, that array was initialized, and in that first, like in the for loop, int I equals to array length minus 1, and I is less than array length, and I was decremented, and it was
Okay.
not showing any printout. So I said that there is condition is not satisfied because I was initialized to array of length minus 1, but in the condition it was written that I should be greater than array of length.
Correct. So
Yeah.
was that satisfying?
No, the
So you
condition.
understood you understood the point, right? I mean, why it
Yeah.
was not. Yeah.
Yeah, means I said that same thing, but you said me that I have put decrement there. So it should print something. So after that I got confused. I mean,
Okay.
usually like
Okay. I think we will start the session now. Afterwards we can discuss Kavita. Okay. So
yeah,
if you have
but that answer is right,
yeah.
right? Because when the condition is satisfied, then only it will go for it will print. Then next round it will start increment, right? In any loop, in any for loop.
Yeah. Correct.
Yeah. Okay.
Okay.
Thank you, sir.
Yeah. Sure. Kavita. Yeah. Good evening, everyone. Let's get started with the session. So Kavita had a small doubt, so we were discussing about that. Okay. Welcome all. So let's see what do we have in today's session. So we will continue with our control statements. Okay, today we will discuss about jump statements. Java provides 3 jump statements. So we'll see what are those things, and then we move on to bitwise operators and operator precedence. And these two topics, bitwise and operator precedence, I did not cover during operators. Okay. So in the last session, we covered loop statements, wherein we discussed while loop, do while loop, for loop, and enhanced for loop. Can you all hear me? Am I audible? Okay. Yeah. Thanks, Kavita. So as I mentioned, Java supports 3 jump statements. They are break, continue, and return statement. Okay. So one of the examples, we'll start with break statement. So one of the example which we saw in our last session was using break within a switch statement, right? So what, like in each case, we'll have sequence of statements. Okay, within switch we will have a sequence of statements. So in order to terminate out of a particular sequence of statements, we use break statement. Okay, so we have seen like for each case we had a set of statements. Okay, and then at the end we included break statement. So if we don't include break statement, you know how the execution happens. It falls. The execution, the flow of execution falls from one case to other if we don't have the break statement. Okay. The second use of a break statement is to exit out of a loop. Okay. So we can give a condition saying like, okay, for if this particular condition is satisfied, come out of this particular loop. Okay, we will see an example on all these things. Okay, and third way of using a break statement is as a go-to statement. So in other languages we have some statement called go-to. Okay, similar to that one we can use break. So like we can give the keyword break and then give the label of the statement where it has to go. Okay, it will go to that particular statement. That is what is meant by go-to statement. So break statement can be used in 3 different scenarios, that is within switch and within loop to exit out of it, and then as a go-to statement. Okay, and then there is second jump statement, which is continue. Okay, we will see a simple examples on all these things. So let me cover the topic first. Okay, so continue is, it is like say for example your loop is running. Okay, I mean you are looping through set of statements similar to break statement, right? So what do you want to do is, okay, a particular condition, you don't want to execute the rest of the loop statements, rest of the loop statements. Okay, say for example you have 10 statements within a loop, and in between you have one if statement. Okay, once the if statement is continued, say for example after 5 statements you have an if statement, and then after if statement rest of the 5 statements are there out of 10 statements. Okay, so if the what you want to do is, if the if statement continues and if the if statement is true, you don't want to continue with the last 5 statements, that is 6 to 10 statements, but you want to start the continuation, I mean the loop again. Okay, so that is when you use continue statement. Okay, so return statement, third one is return statement, which is basically used in method to return from a particular method to the Kali. Okay, so we'll see all these things, but return statements, when we discuss about methods, we will discuss return in detail. Okay, there are different forms of return statements that we will see. Okay, so let us continue with the break statement and continue statement with an example. Okay. So as we have seen the break statement usage in our last session with the switch statement, I'll continue with the loops with the other 2 examples, other 2 uses of break statement. Okay, one is we will use it within loop statement. Okay, so what I'm trying to do here is print the value of I. Okay, I'm printing the value of I. Okay, so it is printing from 0 to 9. We all can see, right? Can all of you see my screen? Can all of you see my screen? Please confirm. Okay, yeah, thanks, Kavita. So say for example, I don't want to print, we are printing from 0 to 9, right? Say for example, I don't want to print 4. Okay, so what I will do is, after 4 I don't want to print anything. Okay, if I is equal to 4, if I is equal to 4, break. Okay, so what will happen now? So this is the earlier output, the first output. We are saying 0 to 9 it is printing. So now we are printing only 4 elements. Okay, if I is equal to 4, come out of it. Okay, we are not printing the I statement. Okay, or if you want to print only here, you can print all these things here also. Okay, so if I is here, what is happening? When I is equal to 4, then only we are printing the value of I. Otherwise, we are not printing any other. So you can, you can use these things in a different ways. Okay, so that's what if you put it here, it prints 0 to 3. Okay, so what exactly is happening? Yes, so what exactly is happening? When I is equal to 4, we are coming out of this particular loop. So we are breaking out of this loop. Okay, so this is another usage of the break statement. Okay, within the loop, to come out of a loop, you can use break statement. Okay, this third usage is go to statement. Okay, so this particular way of using break is not so good. So we rarely use this way of break statement. Okay, so we know that we can create a block of statement by opening and closing this thing, flag brackets, right? Curly braces. Okay, so let me change value of okay. Okay, so it is within this. Let us make this as int I is equal to 0. Okay, so let us not print this. So let us try to print this. So we are printing the value of I is 4. Correct, right? So now what I will do within this, I will increment I again. Okay, I plus plus ln. Okay, right. So what is happening here? So the value of I is 5. Okay, incremented value is 5. So again, within this, let me increment one more time. A plus plus. Okay. So now we are getting this particular value. So initially the value of I is 4. Then we increment it, it becomes 5. Then we increment it, it becomes 6. Okay. So there is something called as labeling these statements. Okay, labeling. So what we can do is we can just name it. Okay, outer. Okay, so you can give an identifier and then colon. Okay, that is okay. So inner, we can say inner 1 and then inner 2, inner block you can mention 2. Okay, inner block 1, outer block 1. Okay, so this is what is labeling some statements. Okay, so what we did, we have given some identifier, and then the identifier follows colon. Okay, so identifier follows colon. So now what do I want to do now? I want to use break statement. Okay, so let us try to use break statement here. Okay, break to inner block 2. Okay, break to inner block 2. So let's see what happens. Okay, So from inner you can go outside, okay? So that is why it was showing error. So if you try to put it here, or if you try to put this here with this value, okay, it will show error, right? It will show error. So what you are doing, you have to break out from inner statement to outer statement. This can be used wherever you want, wherever you have a set of code, that is block of code, okay? Not within your the whatever the way I am showing. It is just a block of statement I am showing. So this, wherever you can use block of statement, there you can use this form of break statement, okay? So why is this showing error here? Because the inner block 2 is inside inner block 1, okay? So why do we use this break statement? We use it to break out from inner block to outer block, okay? Inner block to outer block. So let's see what happens. Let us have one more after this, okay? So incremented value of I, where is this? Okay, so unreachable code. Okay, so since we are breaking out of inner block here, this becomes unreachable code. That's why it is showing error. Okay, so let us try to do and then try to print it here. Okay, this is also unreachable code because we are breaking out from that particular block. Okay, let's try to execute this. Okay, let's try to put this block here. Okay, so now let us try to, okay, so okay, so this becomes, give me a second, let me try this. Okay, everything after break statement, whatever I'm trying, it is showing like it is a unreachable code. Okay, in Java, any statement which cannot be reached is a error, compile time error. So I'm thinking where to put this. So even if I try to put it here, it will show error. Uh, okay, so I'll get back to you on this one. Okay, so let us see. So whatever the statement that I'm typing after block statement, so that is kind of like showing it as unreachable code. Okay, so I will continue with the other topics. So I'll get back to you on this one. Okay. So let's move on to the next topic, that is bitwise operators. Okay, so we have covered various other operators, that is arithmetic operators, relational operators, logical operators, and others. Okay, so the bitwise operators I did not cover because we just wanted to understand few more topics related to bitwise operators. That's why. Okay, so where can you apply these bitwise operators, or to which data types can you apply this bitwise operators? We can okay. So we can apply this bitwise operators to any integer types, okay, including char type. Okay, so we can apply to any of these things: long, integer, short, byte, and char type. Okay, so why do we call this as a bitwise operator? Okay, so say for example I have 10, decimal 10. Okay, it can be represented as 1010. Okay, this is 1 bit, this is 1 bit, this is 1 bit, and this is 1 bit. So there are 4 bits, right? There are 4 bits. Okay. Yeah, yeah. Yeah. Okay. So yeah, I'll come to your point here. Yeah, that's a good one. Okay. So so whenever, let's try like what we are trying to do here is how this happens. It happens on individual bits, okay, of an operand. Say for example, I have a unary NOT operator. So let us consider this one. So what it does, it inverts what are the bits that I have. Okay, 1 0 1 0. Okay, it means it becomes 0 1 0 1. It is operating on individual bits. That is why these operators are called as bitwise operators. Say for example, I want to OR two numbers 1 0 1 0. Okay, so with OR 1 0 1 0. Okay, so it will be like 0 1 0 1 only. So what is happening when we do any operation on using any of these operators? It works on individual bits of 2 operands. Okay, that is why this is called as bitwise operators. These are called as bitwise operators. So there are different bitwise operators. One is unary NOT, bitwise AND, or we know the operations of AND and OR, right? So we have seen the truth table for AND, OR, XOR, all those things. Okay, there are other things which are like right shift, zero fill, left shift, and similar to other operators, we have like bitwise AND and assignment. Okay, bitwise AND and assignment, OR and assignment, XOR and assignment, right shift and assignment, left shift and assignment, left shift, right fill, right shift, zero fill. Okay, we'll see an example with all these operators. Okay, so what exactly is happening is like we know, like in order to understand how these operators operate, we need to understand 2 things: how Java stores integer values, all different types of integer values, that is long, long int, short, byte, and char. Okay, and then how the negative numbers are represented in Java. Okay, so we know all numeric types are of sign types, right? That is the leftmost bit, the most significant bit. Okay, for example, okay, this is the 0th bit, this is the 31st bit. Okay, the most significant, this is the least significant bit, and this is the most significant bit. Okay, so the most significant bit is always used for sign. The most significant bit is always used for sign. Okay, if the most significant bit is 0, if the value of this most significant bit is 0, it means it is either 0 or positive number. Okay, if it is 1, it is negative number. Okay, it is negative number. Okay, so that is why the most significant bit is used to represent the sign of a number. Based on what value is there on the most significant bit, the number is decided, like whether it's a positive number or negative number. So let us take an example. Okay, in decimal we represent 42. Okay, the decimal number 42 is represented by binary with this 0 0 1 0 1 0 1 0. Okay, so if we write those things in on powers of 2, okay, so that we get the decimal equivalent as these values. Okay, so 32, 8 and 2, that is the number. We already know how to convert the decimal to, or binary number to decimal, right? This is how we convert it. So as we know, signed numbers, all numbers are signed numbers, but how negative numbers are represented in Java. So this is almost like all other languages, similar to all other languages. So in Java, we use or we encode all the numbers, negative numbers, using what is called as 2's complement. Okay, we encode all numbers, negative numbers, as 2's complement. So how we arrive at 2's complement? We first take the positive number, okay, and then invert all the bits of the positive number. This is what is the process of 2's complement. Okay, 2's complement step. Okay, invert all the bits of positive number. Okay, and then add 1 to that result. That is when we get the 2's complement of a number. Okay, 2's complement of a number. So so if I want the 2's complement of this number 42, right? 42, if I want the 2's complement of this number, what I should do? The value is 0 0 1 0 1 0 1 0. So what I should do? I have to invert all the bits. Okay, I have to invert all the bits. That is, inversion is nothing but making each bit or inverting each bit. Inverting is nothing but if you have 0, make it 1, or if you have 1, make it 0, each bit. Okay, so with that logic, this becomes 1 1 0 1 0 1 0 1. Okay, what I have done, 0 to 1, 1 to 0, that is what is the conversion. Okay, so this is not the 2's complement. We have to add 1 to the result. Okay, so it becomes 1 plus 1 is what? 0. So we carry over 1 1. So 1 0 1 0 1 1. Okay, so the 2's complement of 0, this is the value I am taking, 0 1 0 1 0 1 0 is 1 1 0 1 0 1 1 0. This is the value that we got here. Okay, that is how we get a 2's complement of, that is how we get 2's complement of any number. Okay, whether it is positive or negative. But here this is 0, so it is a positive number. So since this is 1, it will be a negative number. Okay, so let's see how this is applied to a negative number. Okay, so what first step is to take the positive, take the positive number and convert it into binary. Okay, and then so this is what we got, right, in our previous slide. So invert the bits. You see, as you can see, zeros are converted to 1 and ones are converted to zeros. Okay, and then when you add 1 to it, okay, so for this row we are adding 1. Okay, so what is the result? We got this result. Okay, so that is 1 1 0 1 0 1 1 0. Okay, so remove this, try to calculate what is the value and subtract it by 128, because that is the max value that we can have for a byte. Okay, so we have taken 8 bits, right? So for a byte, 128. So subtract whatever the value that we get, right? So binary to decimal, you convert it and then subtract it and then add. Since it is minus since 1 represents minus, add 1 to the result. Add minus to the result. Okay, add minus to the result. We will get the negative value is 42. Try that exercise and let me know if you have any doubts regarding that one. Okay, so let us continue to this one. Okay, so what Hugh was telling is yes, so outer block. Okay, so if I is equal to 6, if I is equal to 6, break to outer block. Otherwise, incline okay, let us try to comment this part. Okay, this is what the clue which Hugh gave me. So now we are not seeing any unreachable code error, right? So let us try to execute this. Let's see what exactly happens. Let us try to comment this part. Let's not print this one, so that we can concentrate only on the output that we are concentrating on. Okay, so first, okay, let us print outer block value, then one value, two value. Okay, let us try to run this. Okay, so the value of I in outer block is 4. Okay, the value of I in outer block is 4. So it executed, incremented the value of I, incremented value of I within inner block 1. So we got this one. Okay, now we are printing this value of I, that is 5 only. Then it comes and executes this one. Okay, so that is normal execution. Okay, so all the 4 print statements it is printing: outer block, this one, this one, this one, and this one. Okay, but let us see what happens if we uncomment this one. Okay, I'll come to you, artist. Okay, let us uncomment this statement, which makes the value of I to 6. Okay, then this particular statement gets executed. Okay, let's see whether this will get executed or not. So initially, what happened? We can see this one, I is not equal to 6. Okay, so let us see what exactly 4 statements it is printing. After uncommenting this particular statement, what will happen? Okay, you can see what exactly happened. Okay, so after I plus plus, we are printing. So value of I is 6, but we are executing this statement. That is, if I is equal to 6, break out of outer block, break out to outer block. So this statement will not get executed. Okay, as you can see, this statement will not get executed. What about if we put a statement here, which is outer block, this is inner block. Okay, inside this, let us print one more. Inner block 1. So it goes out of outer block, right? Okay, inner block incremented value, inner block 1. Let us print this one here. Let us print inner block 2, and this one is Okay, then we will try to do the same thing for outer block as well. Okay, outer block, so outer block. Okay, let us see what will get printed. So it broke out of outer block. Okay, let us try to make this inner block 1. Inner block 1. Okay, so we can see what is the result. So what exactly is happening is, so hope all of you can see my screen. So initially what it did, so it printed this particular print statement, and then it came inside this. Okay, then it came inside this. Okay, now the condition is true. What exactly is happening? It is breaking out of inner block 2 and it is coming here. Okay, so it is breaking out of, okay, so it is breaking out of inner block itself, inner block 1 itself. That's totally breaking out of the inner block itself, and then this particular statement is printed. Yeah, Mohammed. Yeah, Atif, I'll be sending the code, all this code. Okay, all this code I'll be sending. Okay, so if you need, I mean, let me see. I can see the code here for other sessions also. So what Atif is asking is he wanted to have this code to be shared with all of you. That's what Atif wanted. So I will share this with everyone. So you can get in touch with Yuraj for getting the source code for all these things. Okay. So if you have any doubts for all this, I mean with these codes, please let me know. I will check. Okay, I'll get back to you. If you have any doubts, please send me an email to Intuition at intuitionjavatraining@gmail.com. So I'll respond to your emails. Okay. So what exactly we did? Okay, this is one thing. So let's go to the other bitwise operators. So okay. So what I am doing here is I have taken a few of the operators and I have tried. Okay, I think most of the operators I have tried here. So what I am doing here is, so I have taken. Let me try to comment out unwanted things. Okay. So we'll unblock it statement by statement. Okay. Okay. So so what I have done here is, let me take a pen here. Yeah, Neha. Yeah, you can talk to for these things, right? You can directly talk to Yuraj. Neha is asking for slides. You can directly talk to Yuraj regarding these things, like recordings and slides and codes, right? You can directly talk to Yuraj. He'll be able to help you. All okay? Okay, Neha? Yeah. So what I have done here is I have taken 2 integers. Okay. I've taken 2 integers. So this is what I'm all the methods in Java, right? They are kind of like intuitive. So the moment you read the methods, right? The moment you read the methods, you'll understand what exactly that particular method is doing. Okay. So what it is doing. So this is an integer class. Okay. This is an integer class. We usually call that as a wrapper class. Okay. It is a wrapper class. Wrapper class to what? Wrapper class to primitive int data type. Okay. Wrapper class to primitive data type. Okay. So now it is not like earlier, like when it was when we were having JDK5 and all, not JDK, before JDK5 and all, we used to, I mean, we know what is typecasting, right? So if you want the object representation of a primitive data type, we used to cache the data to this particular class. For example, I have int I is equal to 10. Okay. If I want object representation of int, this is before JDK 5. Okay, this is the JDK 5. Whatever I'm discussing now, that is before JDK 5. So what we used to do is to get object representation. Object representation of any primitive data type. Okay, object representation of any primitive data type. We used to do what is known as casting. Okay, typecasting. We know what is typecasting, right? How to do a typecasting. What we used to do is, no, we used to create a object, new integer of this particular value. Okay, this used to kind of like give. That is why I am mentioning like it is before JDK5. Okay, before JDK5. What we used to do, that is what I'm telling. So to get an object of this value, right? Integer, the object of integer for int primitive data type, we used to do like this. We used to create a new object. It creates a new object on which, say for example, integer int obj is equal to this one. Okay, so we used to get integer object whose value is this one, 10. Whatever the value that we assign to I, because we are using I here. Okay, we are using I here. So this is the object which represents this value. Okay, why do we go for object? This is a class. Class will have methods which you can use it on this value. Okay, so that is why I'm using this one, integer dot to binary of 10. Okay, to binary of 10. So what it gives me, so I have sorry, here I should have mentioned the I. Okay, like I have mentioned it here. Okay, so what I have done here is I have taken two integers and I'm converting the integers 10 and 20 to binary string. So what is 10? If you convert it into binary, 1010, 20, it is 10101. Okay, let us try to print. Yeah, Kavita is telling whatever we discussed just now, right? Object of an integer. So that is auto boxing and unboxing. So this is not auto boxing and unboxing because we are creating the object itself, right? So after from JDK5, Java introduced, I mean Oracle or Sun Microsystem introduced what is known as auto boxing and unboxing. Auto boxing and unboxing. Okay. Say for example, so earlier, let me take an example. Int I is equal to 10. Okay. Now, say for example, I want, or if a method is taking, say for example, a method say x, y, z method is taking integer as argument. Okay, integer as argument, and if I call that method x, y, z with I, that is this I, this will be automatically converted to integer object, because here the xyz method is expecting integer object. So that is what is called auto boxing. Okay, unboxing is I have I. Okay, that is this I, and I have say for example int object. Okay, I can use int obj here. Okay, This is an object, okay, but this is a primitive data type. So the value within this particular object, that is when we passed it here, right, that thing will be unboxed and then assigned to this I, that is unboxing. We'll see more examples when we discuss about different topics like auto boxing, unboxing, and generics. There are so many things, okay, during the topic. Later sessions we will see those things, okay. So we are discussing this particular point. What we are doing here, we will take an integer and then convert it into binary string, okay. That is what we are printing here. So let us see. So this is 10 is what? 1010. This is 10101 okay. So let us try to run this particular example. Okay, you can see the result here. Binary representation of 10 is 1010, 20 is 10100. Okay. Just wanted to show you how you can you can also take an array with these strings, okay, and then put it and then you can manipulate things, okay. So let us take what happens when we try to do when we try to use not operator, okay. When we try to use not operator, okay. So when we try to do not operator, we know it inverts individual bits of a operand, right? So we are using I here and we are using j here, okay. So I is what? 1010, okay. Inversion of I is what? We will invert it. Whatever is 1, we will convert it into, or we will write 0. Whatever is 0, we will write 1, okay. 0 1 0 1, okay. That should be the value when we try to print I here, okay. Similarly, 1 for 20, 1 0 1 0 0. So what is the inversion of this? 0 1 0 1 1, okay. Let us try to print that value and see whether we get the same values, okay. Okay, so we did not get what we were discussing, right? Can anyone tell why this 111s came? Can anyone guess why we got these 111s here and this here? Just think, you'll get the answer. So what are we using here? Yeah, what are we using here? It is int, right? We are using int. Data type is int. So data type what we are using there is int. So what is the integer length? It is 32 bits, right? 32 bits, right? So how do you write 32 bits? So last 4 bits will be 1 0 1 0, but rest of the other bits will be 0. Okay, and this is 0th bit. This is 31st bit. Okay, that is why whenever we do inversion, this particular bit, 0 particular bit becomes 1, this becomes 0, this becomes 1, this becomes 0, and all others, they are zeros, right? All others are zeros, so they will become 1 1 1. Okay, that is why we got that result. Let us see the OR result. OR of I and j. Okay, OR of I and j. What is the result? So what do we have for I and j? We have I or j. Okay, so that is your 1 0 1 0 1 0 1 0 0, right? So we know how the OR works, right? OR operator works. 0 0 means 0. If any one of the operator is 1, or any one of the bits are, because this operates on individual bits, this will become 1. So this will become 1, this will become 1, this will be 0, this will become 1. This is the result of I or J. Okay. Similarly, I and J, what is the result? 0 1 0 1 0 1 0 1 0 1. Okay. So 0 and 1 for AND it is 0 only, because if any one of the operand is 0 or false, okay, the result will be false. So this will also be 0. 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 Okay. The result will be 0 for AND operation. Let us see the result. Okay. Let us see whether we are getting the same values what we have discussed now. So the result is 0 here, and the result here is 1 1 1 1 0, as we got it here, Okay. So remember, these are in bitwise operators. So it operates on individual bits. Okay. So can anyone tell me what is the difference between, we have seen logical operators, okay? Logical operators and the bitwise operators. Bitwise operators. Can anyone tell me the difference between logical operators and bitwise operators? They look similar, right? And is and is. We will write for logical operators. We write and as and we have for OR we have this one. Here also bitwise operator also we have the same thing. What is the difference between bitwise operator and logical operator? What is the difference? Okay, find out what is the difference between logical operators and bitwise operators. Okay, and let me know in our next session. Okay, that is tomorrow's session. Okay. Okay, so we got the result for AND and OR. Let us see what is next. Okay, XOR. XOR is like you will have one. Yeah, he is telling bitwise operators deal with machine language, I believe. Okay, he is telling bitwise operators operate on machine language. Yeah, in some way you are correct. Okay, so what exactly is happening here is logical operators. Okay, so logical operators operate only on Boolean values, right? Logical operators operate only on Boolean values. So what are the Boolean values do we have? True or false. Okay, whenever you are using a logical operator, the operand should result. It can be a relational expression that results in either true or false. Okay, whatever the compound expression that you have. Okay, if you are using logical operators, it will operate only on values of true or false. Okay, if you are using a relational operator here and using OR here or AND here, these values should be either true or false. We are not concentrating on individual bits, 0 or 1. 0 or 1. We are not concentrating on zeros or 1. Okay, but here bitwise operators, they operate on individual bits. not on true or false. Here we are not talking about Boolean values at all. We are talking only about zeros and ones. Okay, zeros and ones. We are only talking about bits, not true or false. Did you understand, Hugh, what we are talking here? Did you get? Did everyone understand what I just discussed about logical operators and Boolean operators? Logical operators and bitwise operators. Okay. Yeah. Okay. Yeah. Let's see what is XOR. So we have I as 0 1 0 1 0, J as 1 0 1 0 0. Okay. XOR is it will result 1 only when there is a 0 and 1. Okay. So here 1 1 1 1 0. If it is 1 and 1, it will be 0. If it is 0 and 0, it will be 0. That is the XOR condition. Okay. If two operates are equal, if two operands are equal, bitwise operands. Okay. Bitwise operands are equal, that will be, the result will be 0. If they are different, 0 and 1, the result will be 1. Okay. So let us see whether we are getting that result. Okay, so you can see the same result, right? Whatever the results that we got here, we are getting the same result here, right? That's how XOR works. Okay, let us see some shift operators here. So right shift and left shift. Okay, what it does is, so you notice here what we have done. So now you can clearly understand what exactly is bitwise operators. Okay, so we mentioned some value here. Okay, some value. Okay, then we will use right shift and the number of times the bit should move. For example, if I say, let us take this expression. Okay, what I'm telling, move the bits that is there in I 2 times to right. Move bits that are there in I right 2 times. Okay, what exactly happens? So this is the 31st bit. This is our last 4 bits. Okay, this is last 4 bits. What I will do, I will move these bits to right 2 times. First time this will be moved out. The result will be 1 0 1. Okay, this is first right shift. This is first right shift. Okay, then for the second right shift, this 1 will be moved out. Okay, so the result will be, this is 31st. The result will be 1 0. Okay, for right shift. Okay, for right shift. For right shift, here we should get the value as 1 0. This is not 10. Remember, this is not 10. This is 1 0. That is your decimal number. Decimal number is 2 power 0, 2 power 1. That is your 2. Value 2 in 10 in decimals. This is binary. Okay. In this case, yeah, here I should have mentioned like this. So in this case, what I am doing, I am shifting the bits left. Okay. So what exactly happens? 0. This is 31st. Okay. Then we have 0 on 0. What I am doing, I am shifting these bits. That is where we are. That is why we are talking about bitwise operators. That is why they are called bitwise operators. We are operating on individual bits. We are operating on individual bits, 0 and 1. Okay. So what exactly happens? 1 0 1 0 0. Okay. Then second second left shift 1 0 1 0 0 0. This is what is the value after 2 left shifts. Okay, let us see whether we are getting those values. Yeah, so let me erase everything. Okay, so this is our 10, that is 1 0 1 0. We moved out these two things, the rest is 2. This is 2 in 10 decimal numbers. Okay, when we moved left 2 times, 2 zeros got appended to the existing value, that is our 10 1 0 1 0. Okay, that is why we got the result 0 0. Okay, are you all understanding what I'm discussing here, what we are all discussing here? Okay, cool. Yeah, thanks you. Okay, so let's move on to the next operator. So this is zero fill right shift. So at the end, the zeros will be added. Okay, so you will not see with these examples, whatever the examples are we have taken, that is I is equal to 10 and what is it? The other one I is equal to 20, right? So you will not be able to see the exact result. What we can do is, for bit, what we can do is we can do this one. Let me try this one. Okay. Byte B is equal to 127. Okay. Let's see whether we will get this. Okay, let us try to print 2 binary string. It is not there. Hold on for a second. Let us try to do this one. Okay, it is giving some number format exception. Okay. So what is the maximum value that we can give? So I'm just trying one simple example. Let me see whether we are getting it. Okay. just to show how that affects. Okay. So here, what is happening is the value of value of x here is value of x here is. So you can see all ones here, right? But it is still not 32 bits, right? 1. Okay. Now let us try this one. Okay. Let us try to do this one. Okay. And let us try to do that. Okay. I was expecting zero fill is, I think it is rotating. The numbers are, the bits are rotating, I guess. So I think the okay. So what exactly is happening is so what I am doing here, 10 times I am moving the value or the bits from x. Okay, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, these 10 bits are moved out. Okay, and then what is exactly happening? Zeros are added, similar number of zeros are added. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22. Okay, so let us count this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So what exactly is happening? Whatever the value that I specified, they are moved out and behind zeros are appended. Okay, that is what is what is that? Zero filling the zeros when you move towards the right. Okay, left shift, this operator is not there, so that is why we used only right shift zero fill operator. Okay, the last one we have is assignment operator. Okay, so the assignment operator is similar like how we did. So this one is similar to this one is equivalent to this one. I is equal to I, right shift 3 times and then assign the value result to this one. Okay, so that is what we are seeing here. That is the value that we are seeing here. Okay, one. So right shift, when you do 3 times, this is all these three things are gone. So only one is left. That is what is left here. Okay, so try these things. In real time, it will not be. I mean, there are places where these bitwise operators will be used. Say, for example, in cryptography or in network programming and all. Network programming, in the sense like. Not exactly, there is one particular package in Java that is java.net, not in those things, but actual network programming, right? So all the traffic, network traffic is through zeros and ones only. The communication, whatever you do, that is like when you're talking on your mobile or which are the electronic device that you use, everything is done in zeros and ones only. Okay, while doing or while programming or while writing applications for such devices, electronic devices, right? Say for example, network devices, how network communication has to happen, all those things, right? In those scenarios, you'll use these bitwise operators extensively. Also, in cryptography, okay, you convert what are the say for example, simple password, whatever the password that you enter, right? If you want to convert or encode it into some form, okay, you convert all these things, all the passwords that you enter into bits, and then manipulate bits based on whatever the format that you want to convert. In those things, in those places, we will use these bitwise operators used for network, yeah, the subnetting and all those things here, correct. So that is where the application of these bitwise operators come into the picture. Normally, during our web applications and all those things, we'll not use that much. I have seen this one in one of our application, but that is what it is for conversion of one format to other format. Okay, so what we are doing, we'll take whatever the password that is entered for an application to log in, right? That will be checked with a value that is there in database. Okay, that database is encoded value. So the password which is entered in the while logging into the application, that is converted into that particular encoded value and compared whether the user is a valid user or not. Then the authentication to the application is given. Okay. So I think only one last topic is left. That is our operator precedence. Okay. So any Java operators, they have two properties. Let me finish this one. Okay. From tomorrow session, we'll start object-oriented programming. Okay. What are classes and all those things. So operators have two properties associated with them. One is precedence and associativity. So precedence is like the priority. Say for example, you have an expression, arithmetic expression, wherein you have plus and star. That is multiplication and division, as shown in this particular example. Okay, as shown in this particular example. Okay, so which one will get executed first? Is it like this way or is it this way? What is the result of this one? Okay, that is what is done using your operator precedence. So which operator has to execute first? Which operator has to execute first? That is what is your precedence. Okay. So this will be like the value of this will be 1 plus 2 star 5 will be 1 plus 2 into 5. That is 11. It is not 3 plus 5. That is, it is not like, okay, 3 into 5. It is not this one. Okay. So multiplication has higher precedence than addition. Okay. So whenever an expression is there, whenever you see an expression that has the same, I mean, operators within the same, say for example, the same hierarchy, right? So you see this one and this one. So in such scenarios, what exactly happens is multiplication. In these kinds of scenarios, multiplication will be taken, I mean, multiplication will be done first and then addition operator is done. Okay, so highest priority operator will be executed first and then higher and then the high one. Okay, so like first this one and then this one. Associativity is the direction of operation. So in this case, what exactly is happening? Okay, the operators are verified from left to right. Okay, 1 plus 2 star 5. So it is verified like this, and then first multiplication is done, then addition is done. Okay, but in this case, the associativity is from left, right to left. Sorry, this is left to right. This is right to left. Okay, so what exactly happens in this? That is our assignment, right? Assignment always is the associativity is right to left. So what exactly is happening here? C is assigned value 8 first, and then the result is assigned to B. Okay, then here also first this is similar to like C is assigned to 8 is assigned to C first, then the value of C is assigned to B, and then the value of B is assigned to A. That is what associativity. That is your direction in which the operators get executed. Okay, these two things are associated with your operators, and whenever this is the table which explains the operator precedence. Okay, this parenthesis and square brackets, they have highest precedence, and equal has the lowest precedence. That means if you have an expression like this arithmetic expression 1 plus 2 star 5, so that will go through this operator precedence. Okay, say for example, like say this has the highest precedence than this one plus 1, right? So that is why multiplication is done before addition is done. Okay, but if you have any confusion, with this operator precedence, right? Whenever you are doing some, whenever you see some expressions and all, or whenever you are writing some expressions, you can always use parentheses. Okay, why do we use parentheses? To override operator precedence. So in this case, if you want 1 plus 2 star, so let me take this way. So we have this expression, right? Without anything, without any operators or parentheses, right? Sorry, again I put this one as 1 plus 2 star 5. Okay, this is similar to 1 plus 2 star 5. Okay, can we make this value? Yes, we can do that one using parentheses. We can override the operator precedence here by parentheses 1 plus 2 star 5. So this will be evaluated like first this addition will be done, that is 3, then multiplication, that is we will get the value 15. Okay, so parentheses are used for overriding operator precedence. So whenever you have any doubts with respect to or whenever you are writing any expression, right, you can use parentheses to kind of like avoid your confusion. Okay. Okay, let's move on to the next slide. So this is the operator precedence, and then yeah, if you have any questions, we can discuss that now. Otherwise, we can conclude this session. Anyone has any doubts with respect to whatever the topics that we discussed now? Please let me know. Okay. Yeah. Thanks everyone. Thanks a lot. Yeah, Pawan. Do you have any question, Pawan? Any doubt? I'm not able to unmute you. Can you just post your question, Pawan, if you have any doubts?
Hello.